All right, hey guys, my name is Abhi Aiyer. I'm a software engineer at workpop.com in Los Angeles, California, and I love data. Not just any type of data. I love fetching data. I like mutating data. That's my jam, and that's what I do. That's why I wanted to bring people in our industry, in our community, that make that their living and talk about it. So today I have Jon. Can you introduce yourself, Jon?
Yeah, my name is Jon Wong. I'm an engineer at Coursera. I'm on the front end infrastructure team, and I focus a lot on the front end parts of our stack. Obviously.
Awesome. And we have Bryan. Could you
Yeah, I'm Bryan, also on the front end infrastructure team, mostly working on back end related things that help front end engineers with their work.
Awesome. So the reason why I got you guys on the recording today is you guys are using GraphQL in production, and GraphQL pretty much has come on the scene in this last year with huge force. Ever since the open source of it, and then the GraphQL conference, and then Apollo coming out, kind of putting all their content out. GraphQL has really gotten this big buzz, right? Could you guys explain to me your infrastructure before GraphQL?
Sure. So Coursera has kind of gone through a couple of different evolutions. We started off with a very basic PHP application that was all server rendered. Mm-hmm. We had some JavaScript on the front end to make things look nicer, but it was mostly just you go between pages in PHP, they're rendered on the server.
Yeah.
And we moved to more of a single page app approach. So started using like REST APIs in Django and JavaScript on the front end. I would call those APIs, load all the data, and basically we would, for every different page, we'd make a new API for that and figure out all the data we needed, put it in that API, and then just ship that all to the front end. And anytime we made a change, the front end and back end were changed in sync. And then we kind of realized that REST was kind of a thing that we needed to do as we were growing. More people were working on APIs, and we needed to do more on the back end also. So we moved to Scala and Play Framework and used that to write APIs. Tried to keep them as RESTful as possible. And as we were going, we realized that a lot of the APIs were pretty similar and we were just writing the same thing over and over. So we actually wrote our own API library called Snaptime that standardized these REST APIs. So then we've been using that for a while, and we basically have like 800 different APIs right now. They're just very standard REST APIs. They have some model definition. They just return data, and we use that all on the front end.
Wow, nice. So you guys pretty much rolled your own stack, which, a lot of companies do that, and I think that's the right thing to do when you're in a jam, right? In my experience, the minute your team starts scaling quickly, you kind of don't have the time to kind of plan out that scaling part, right? So you have people who know how to build REST APIs, but if you're the architect, you really know how to build REST APIs, right? And then like a couple of days later, then there's like 20 new APIs that you never knew about, and they all do the same thing. So yeah, that's cool. So can you explain a little bit more about this Snaptime? Like, what was the goal? Like, what was the problem you guys were really trying to solve, and how did the front end developers like it?
I think a big thing that it solves is just standardization on APIs.
Yeah.
REST APIs, there's some information on like how to write them, but people can interpret everything differently. They could have different response formats. They could take in, like one can take in form body, one can take in JSON. So it's just, we wanted to have just one way that developers wouldn't have to think too much when they were writing an API. This also made it a lot easier for front-end devs because, like I say, once they learn one API, they know all of them. We could write then different utilities on the front end that would parse the APIs, and they would all look they would all be in the same format. They would look the same. So we were able to write a lot of common tooling around that.
Awesome.
So that was, I think, one of the big things that it gained us.
Mm-hmm.
Nice.
Talk about code selection.
Sure.
Yeah. So one of the other cool things about Snaptime for front-end devs was we had a problem where we were building these applications where we were hitting an API and we would take all the data and it would be this humongous chunk of just JSON, and it would be super, super heavy. What Naptime allows us to do is actually allow us to select particular fields on our data. So we don't need to pull the entire set of information for a course. We can pull just the title of the course, the instructors that are related to that course. Sounds kind of like GraphQL. So for front-end devs, that meant getting a lot less data from the backend. We actually ended up writing our own utilities for React, where making those field selections was super simple. It's very similar to GraphQL, but it's not exactly the same.
Nice. So having built your own version of this data layer, what got you guys interested in GraphQL?
I think there were a couple different things. The big one is that just GraphQL is a standard that a lot of people are using. So we wrote this API library on the back, and we wrote helpers on the front end, but everything that we were doing was in-house. So we'd have developers come in on their first day, try to figure things out, and they'd go to Google and search Snaptime or Naptime.js, our front-end library, and they wouldn't actually find anything. Also, whenever there were bugs and people wanted new features, it was people at Coursera that had to go build those. And it took a lot of time. There's a lot to support, and having some community around GraphQL and other people using it, and we could bounce ideas off other people. That was a huge thing that we gained.
That's awesome. Playing devil's advocate for a second. At Coursera, having this internal library, was it hard to maintain because people didn't know how to contribute, or weren't contributing, or didn't want to?
Yeah, so it was actually built out of, we ended up getting I think 4 or 5 devs, and we just sort of hacked it out. And these were people from across the engineering organization. But once it got formalized, it was really hard to determine who actually owned it, who was actually maintaining it. And it was probably a little more complex than it needed to be. It solved the problem, though, and I think that was really good. But then once you start dealing with caching clients, you start dealing with cache issues, cache invalidation. You have to deal with performance issues, updating state across the page, all that sort of stuff. So that's sort of one reason why it has certainly served us really well. But right now we're having a lot of scaling problems with that particular thing.
I see. Yeah. I've seen that before too. You build this library to solve the problem that's in front of you. And you solve it really well, but then the minute some person finds some permutation of another problem, then you have 20 issues backed up, and you have no manpower or resources to do it, probably because you're on a sprint or trying to get something shipped, right? Like you don't have time to write docs or to make something better in a little library that you guys are using. So yeah, I totally get it there. So let's talk about that move to GraphQL then. A lot of people that I've talked to, when they take that plunge and they say, "Hey, I'm sick of writing REST APIs," or I built this library in-house. It kind of does GraphQL, but it's not really there. How do you go and convince your engineering manager, "Hey, I want to use this thing. I know it's something that we played around internally, but I want to use this as the official API." How'd you guys go about that process?
I think our story is actually a lot easier than I expected. So we had this library on the front end that was kind of causing some problems, and we knew that we needed to either invest a lot more into it or find something else. So it was kind of at that time that we were looking at alternatives, and we were also kind of at the time thinking about our long-term architecture. So this was about 6 months or a year ago. We were thinking, what do we want Coursera's stack to look like at the end of 2017? So we were kind of making all these decisions, and we were ready that if there was something we needed to do that took some investment, we were willing to put the time in.
Yeah.
So we kind of played around with GraphQL for a little bit, prototyped what some front-end and back-end things would look like, met with managers and director of engineering, and made the pitch, and it all kind of just fell in place, to be honest.
That's awesome. That's awesome when it works that way, right?
Mm-hmm.
So let's talk about that prototype phase. What kind of features did you pick? Were they live features? Were they being served to actual users?
So we started with 2 different experimental things. One was an internal, we were building a new product internally for deploying applications here at Coursera. And we wanted to test out, I wanted to test out the front-end integration for GraphQL. and all the libraries in that ecosystem, and determine what client we wanted to use. And so I actually ended up not waiting for the backends to have GraphQL capability. I just built all the resolvers on the front end. And so all of those resolvers ended up just proxying back to the existing REST APIs. So I got a really good look at how a front-end developer would use GraphQL. And that was a really good start for that one. The second one was we took a fairly naive read-only page on Coursera and said, there's not a lot of traffic here. No one's actually actively developing this right now. Let's replace it. Let's get all the back-end resources for this particular page to work. And then let's figure out the whole process to make sure that it was at feature parity with the rest of our applications with regards to like server-side rendering and performance and that sort of stuff.
That's awesome. That's awesome. So I'm going to put my VP of engineering hat on and ask you, hey, Brian, hey, Jon, like if you guys are out of the office and your GraphQL implementation is on fire, how'd you guys deal with that? Where's the run book, right? Who's in charge? Who was in charge and things like that? How'd you guys deal with that?
Still trying to figure some of that stuff out. So team one, there are, I guess, 2 or 3 of us working on this a lot, and then we had a couple other people helping out and doing code reviews and just staying on top of what was going on. We also, a lot of the things we rolled out as experiments, so worst case, if we need to like turn it off instantly, we can just roll back to the old page. That was, I think, a configuration that took like 10 seconds to propagate. So we always had that backup there just in case anything didn't go right or somehow the server went down or something. Had that emergency switch there.
Yeah. So a couple companies I've been talking to are worried about taking that first step, right? I've kind of encouraged them the same as you guys. Pick something that nobody's really looking at. Every company has features that nobody looks at, right? But you built them anyway. So that's a perfect thing. Or like moderation or admin tools are perfect places to start. But it's that first feature that has high traffic that is the scariest one, right? You build you ship a new mutation API, and all of a sudden, maybe you're using WebSockets before, and now you're using HTTP, right? And now you have a 500 that you've never seen before in your stack, right? So I think those things are scary for people who are just getting into GraphQL because, these naive things are great, but now like half my traffic is going to this one API and something broke, right? So let's get into that part of it. What do you guys do for performance, and how do you guys monitor your APIs?
Also still figuring this out. We have a lot of instrumentation monitoring. So every single request that goes through, we use Datadog for all of our monitoring and dashboards.
Nice.
So we send the metrics there. So status code, latency it takes for the total request. We also have some lower level things for all the downstream requests. We have timing for that and number of successes and failures there.
Yeah.
To provide a little context on that, we have basically what we call assembler. And assembler is the thing that's running the GraphQL endpoint, but it's not actually handling any of the data that's getting resolved is getting resolved in our downstream services. Mm-hmm. So those services already have a ton of monitoring and performance measurement. To those services, they don't know that it's coming from GraphQL. They just know that it's coming from as if it was just a regular HTTP request. I see. So we have a lot of built-in tooling already.
Okay.
In terms of static analysis, we put a really naive system of basically computing the complexity of a query, and using Snaptime, we know what some queries are going to be more expensive than others. So we could tell at query time this thing is very likely to be very expensive, and if it's very expensive, we're going to not even serve that thing. And so we know when we're testing it out, like, okay, this thing's not going to work right now. It's not performant yet. And then we'd have to work around it or figure out, how do we unblock that particular query.
Interesting. Yeah, we do something very similar where, the downstream parts of your resolver are in your microservices. So what really matters to me, at least for performance of, your GraphQL endpoints is time it takes to to resolve, right? From query start to query finish. And if you use Elasticsearch, and if you have a logger and you can pipe those to Elasticsearch, you can make really nice graphs in Kibana, which is a graphing tool. And And so that's kind of what we do because we have our performance monitoring on our back-end things. I feel like the performance that we're trying to look at is the query time, right?
Mm-hmm.
I think as a front-end developer, it's hard to understand that if I have one resolver that hits 5 microservices, I'm only as fast as my slowest microservice, right? And that was something that we had to learn the hard way because, once you get into GraphQL, you can get so much data, you don't really think about like all the concerns that you might have thought about before. Mm-hmm. Also, another thing with GraphQL is people are writing code, different types of code than they probably used to, right? If I'm a front-end developer, I might just be doing REST fetches and data manipulation on the client or making things beautiful. I never really had to write a resolver or make a schema before, right? Mm-hmm. How do you guys do that in your teams? Are there people who are pretty much GraphQL developers, or are people just everybody's learning it?
So we do something very different than most people for GraphQL stuff. Because we have the Snaptime APIs and they're fully typed with a schema. We have information about the different endpoints available, the models on it. We actually automatically build all of our GraphQL resolvers.
Nice.
We have this service every couple minutes. It pings all of our downstream services and asks them what endpoints are available and what do the schemas look like. And then just takes that all and updates the GraphQL schema. So it's not like GraphQL schemas normally would be, I guess, a little more idiomatic. We have a couple hacks in there to make it work on top of like the first REST endpoint that you go to.
Yeah.
But with all that, then we don't really have to worry about creating the schema. As long as we have these existing APIs, we'll be able to use them with GraphQL.
Yeah. And that's pretty great for our backend developers because they don't have to change the way that they're building their APIs. They just build APIs the same way that they were doing before. So as we're transitioning to GraphQL, they don't have to build specific things with resolvers. They just use the same schema definitions that they were using before. That's super powerful. For front end, one thing that I found that I needed a lot are these ideas of like computed fields or like some new property, some new resolver that doesn't exist on the back end, or it lived in the front end before and now I need to move it to the back end. So there has been some onboarding time for me to go into the back end and add those things. But because I'm not having to deal with a lot of logic, it's actually fairly straightforward for me to boot up a service and say, okay, I need some filtered version of this particular field, or I can add a new relation or a new edge to our graph. Things like that are pretty easy and things that I expect our front-end developers to be building on their own without the need for back-end developers to build those things.
Awesome, cool. So let's take a step outside of Coursera for a second. I'd like to know you guys' involvement in the GraphQL community.
Yeah, so I think Apollo, we haven't talked about that too much yet, but Apollo has been the caching client that we're using right now. It's also a really great community, and they're super open and transparent about the work that they're doing and how people can get involved. Luckily for me, they put out a call for maintainers, and I'm helping to maintain the GraphQL tag library, which you'll probably know is the tag template literal that a lot of the front end that you can use to basically generate GraphQL query documents. And that's being used by Apollo Client, React Apollo, Angular Apollo, or Apollo Angular, things like that. That one's pretty cool. And then also the linter for GraphQL, which is ESLint plugin GraphQL. It's not perfect yet, but it's a pretty good start for GraphQL development.
Nice. What about you, Bryan?
I personally haven't been too involved with open source things just yet. Snaptime itself is open source, so anyone can go and look at that code. All of our GraphQL implementations based on the Sangria library and Scala. I've been waiting until I hit something that doesn't work in the library so I could go fix it. That hasn't actually happened yet. But I think once our implementation is just a little more solid, I'll probably go in and try to find some ways to contribute back to that because it's an incredible library.
Yeah. And to note about the community, there's just a huge community just forming every day around GraphQL. And it's great because, we had GraphQL Conf earlier this year or earlier last year, late last year, whatever. And we're about to have GraphQL Europe coming up, right, this summer. And that's within like a couple months that this boom of people and involvement has risen. And now we have other companies too. We have Shopify, we got GitHub, obviously, Facebook. But a lot of this started from, I feel a lot of this started from the Apollo community. And I put hats off to them, because I was there in MDG headquarters like a couple days before you were even going to go live with this information. We were there for this customer meeting, and they were talking to us saying like, okay, so we were using Meteor.js, and don't really want to talk about why I don't like the subscription system, but they were saying, hey, like, we want to give you MySQL because in Meteor, MongoDB is the default database, and that's how they do their reactivity between client and server. And they're like, hey, we want to do the same reactive experience for you guys, but we can't support every database in the world. So we looked out and we saw there's this GraphQL thing, and I think we can make that reactive so it could fulfill everybody's needs, and all the tickets that we get will finally get closed, because we're not going to support SQL, but we can help you support SQL. So we were there, and we were like, I personally was like, wow, this is amazing, because I don't want to use Mongo anymore. I want to kind of get away from this constant observers on the client and just bringing down my servers all the time. I would love to get involved with GraphQL. So from there, I really tried to get as many people into GraphQL as I could, and it feels like a lot of people did the same thing. And I think we're all here because someone discovered it and told somebody else, and then we all worked on it together. And I think it's great that things are going back and becoming this big. What are your guys' plans for GraphQL internally going for the rest of this year?
I think our long-term goal is, I'm not sure exactly when, sometime soon, we want all of our data requests to go through GraphQL. We see, because we have this kind of abstraction between our existing APIs and GraphQL, everything that's using our APIs now should be able to work with GraphQL, and we only get benefits from it. So we want everything to go through GraphQL within probably the next year.
Awesome.
So, and for front end, that means very likely, what's nice is that we can sort of drop it in on any page. So we're hoping for an app by app, page by page sort of migration. We're toying around with React Native right now too. So it's very likely that the React Native devs are going to be, or the mobile devs are going to be using GraphQL, and very likely using Apollo for that as well. So that'll start unifying how developers at Coursera access their data.
Cool, man. Cool. So let's bring it to Bryan. So you guys are part of this front-end infrastructure team, right? How big is that team? And are you like the lead, or are you like primarily working on that back-end connection? How's that work?
So right now it's three of us, me, Jon, and another guy, Lewis. We don't really have a front-end infrastructure lead right now. We all report to the director of infrastructure. And so I've kind of gone back and forth a lot with back-end and front-end. I think I've worked on a lot of back-end infrastructure stuff before this team kind of blossomed. So I think it makes more sense for me to be working on back-end stuff, and Jon's much better at front-end. But we've seen on like front-end infrastructure things, there's just a lot of need for back-end things. So like building this GraphQL stuff. We're also rebuilding our deployment tooling, and there's a lot of back-end work on just like managing all that, saving the information database, connecting with Jenkins, Fabricator, work on all the build stuff. So even though it's the front-end infrastructure team, there's a lot of back-end work to do.
Nice. Cool. So Jon, let's talk about front-end for a bit too. With GraphQL and like getting into pretty much that style of development, maybe if you're using Angular 2 or React, you're in this component-driven architecture, right? Now, a lot of questions that we get in the Apollo chat room and on forums and all that is, how should I connect my queries to my components, right? And I've heard several different permutations of this. One, you make one query at the top level component and then just pass data all the way down. You batch queries to several components, or you kind of, you build up components, or you co-locate components to every small component. There are a million ways to do this, right? What's Coursera's philosophy on component-driven GraphQL development?
Yeah, so it's a combination of a couple of those things that you mentioned. I started off thinking, okay, the one query to rule them all is going to be really great. Put your fragment definitions next to your components, and because this is a component tree, just stitch it all together using imports or using just like inline fragments, things like that. As we started building it out, I found that was like a really great performance solution. But when you start building components, sibling components that don't have as much correlation to each other, that's where it sort of falls apart. And having to go up and down this gigantic tree of a query just to add a new resource felt a little weird. And so for the most part, we try and say, for things that are of the same application, keep them in the same query. But if there's something like, imagine the page header has to make a call to some API and it's not associated with the page underneath it, you should feel free to use the top level query component and just, create another call. We also batch those up anyway. And because we're using server-side rendering, for the most part, that extra call is worth the encapsulation of that particular data, because on the server, it's a much cheaper call to make than it is on the client.
Definitely. I like that. Yeah, I like that approach. How do you guys keep data fresh for users, right?
That one's we haven't fully figured that out yet. We don't support the mutation API yet. So that means we have to manually refresh some of our data. So far, we've just been using the refetch on the queries and just biting the bullet and saying, we don't have that many writes on our application. So the trade-off is until we can build a good mutation API, we'll just make a call and refetch the query.
Yeah, I think that's understandable. I think it depends on your product, right? I don't imagine Coursera data getting too stale in a short session, right? Like, especially if they're just watching videos and stuff, chilling. Like, they're not like, what's the biggest harm, right? Yeah. But for something that is a very mutative type app, I wonder what the best thing to do for those is, right? Maybe let's talk about a chat app, or maybe like something that you're constantly toggling items, things like that. You're always mutating some element, right? Refetching is pretty hard. It's really hard to justify refetching in that case. But have you guys played with optimistic UI at all?
Mm-hmm. Because we don't have the mutations, we haven't been able to make use of some of those nicer features like optimistic updates.
Yeah.
So I don't have a super great opinion about it yet. Again, just for our apps, we don't have that very common use case where you're writing something and immediately want to update something on the screen. It's cool. The sort of updates we have are like you're enrolling in a course and it'll update. It'll like spin. And that's like the most updated thing that you need to get.
Great. Awesome. All right, guys. So that's pretty much all the questions I have. I have like a million more, but wanted to keep this very short. I instead of doing like how people do picks and stuff like that. I want to do like something different. So I want you guys to just pick something that something interesting that is in the tech community that you'd like to share with whoever watches this video. I'll go first. This podcast or this interview or whatever we're going to do with this it's about the data layer. And GraphQL is not the only solution for data layers. So I just want people to go check out Protobufs or Avro and check out what else is out there. I'm going to try to get those people on this show too, and we can talk about all the different opinions that exist in this space. So that's mine. go check out Avro, go check out Protobufs, and all the like.
You got something?
I don't know. I saw that Google just released, was it Cloud Spanner?
Yeah.
Yeah. That's something I read the paper a while ago, and it seems fascinating that they're able to have the relational database that can handle kind of the scale that it does. I would love to probably just go on Google Cloud and play around with it and see what it can do. I have a feeling that opens up a lot. Once you have relational databases that can handle all of that, I think it's really powerful. And I think the GraphQL tool like Join Monster can then take the GraphQL things and turn it into like a single SQL query. So if you could, I don't know, combine relational databases and the GraphQL stuff and get that all working with just like one query to the database, that could be super performant and
That'd be legit.
a lot.
That'd be legit. That'd be so cool.
I guess my thing that I'm interested in that I haven't had yet a chance to poke into is performance. I think that there's a lot of new tooling out there to address application performance. And that's something that we've never, I don't think front-end apps really had to deal with that much before, because they were sort of static sites that, you don't have a lot of things going on. But just as our applications have grown, we've needed teams like our own front-end infrastructure to handle. And now we also need to really, really deal with performance. And I really love the sort of the progressive web apps that the Google Dev Tools team has been pushing, especially their focus on mobile benchmarks.
Yeah.
For our company in particular, that's really important. Over 2/3 of our learners aren't here in the United States, and very, very many of them have low bandwidth. So that's something to keep reminding ourselves as we're developing on these really nice laptops and on Wi-Fi at Starbucks or something like that.
Yeah.
Has the same access as we do.
Yeah. And a little adage about performance is you can't fix what you can't measure, right? So go find a performance tool and start measuring something, and you can probably fix it, right? Cool. So that's it. I'm going to turn this recording off.